done so, make sure you put a horizon line all the way across. Put it above the midpoint. Don't put it down low. Don't put it up too high. Put it just above the midpoint, halfway down. And again, make sure you put it all the way across too. Okay, so obviously this is a horizon line. So just go ahead and label it. You won't always have to label this stuff, but just label it as HL for horizon line. So remember, the horizon line doubles as it's identical to our eye level in our reality. In our three-dimensional world, we have an eye level. Everybody has one. We don't have a horizon line in our three-dimensional world. But in our two-dimensional world, anytime we're drawing, whether it's we're doing something on paper or we're doing something digital, maybe we're doing a painting on Photoshop or whatever, you have a horizon line. Okay? So anytime we're talking about a horizon line or anytime we're talking about specific terminology and perspective, it's all in reference to what we actually know in our reality. And so I always try to transfer that, what we know, into something two-dimensional. Okay, so here's our horizon line, and halfway in the middle, you don't have to measure. You can measure this if you want to. So this paper is 17 inches wide. So if you were to measure it, you don't have to measure it, but if you wanted to, some people like to fly this way. 8.5 inches. You can put 8.5 right here. Okay. That's the midpoint. That's exact midpoint if you had to measure it. I don't usually measure my midpoint. So this is not just will represent a vanishing point, but this is also our center of vision, CV. Now, what is a center of vision? Center of vision is where, in our reality, it's wherever you're looking. Like, Max is my center of vision. If I was looking at my cabinet back there, that cabinet, the little keyhole, is my center of vision. It's wherever I am focused at, okay? Now, remember, anytime we're doing a drawing in perspective, it's a snapshot in time. So if we're looking at this, if we're looking at my my shadows drawing. Let me drop this down a little bit so we can match this. Okay, so you can see my horizon line here. That becomes my center. That is my center of vision. Remember, in any type of drawing that you're doing or painting, drawing, flat work of any kind, it's all two-dimensional, and it's like a snapshot in time, okay? Like a photograph. Now, we are drawing this moment in time. So because of that, we have a static center of vision. In our reality, our center of vision is moving all the time. If you're watching a film, doesn't matter what film, if the camera is moving, the center of vision is moving at all times, okay? But this is like a moment in time, a snapshot. So the center of vision will also be our vanishing point, okay? So center of vision, vanishing point. So let's talk about what the center of vision actually does. So again, the vanishing point and the center of vision are going to be identical in one-point perspective. I'm going to make just a simple line like this. I'm not measuring this. I don't need to measure anything with this. Just make a line. Make sure it's at least kind of centered with this. And then from the ends, draw 2 lines to the vanishing point. I know for some people this is going to be super basic, and this is why we're doing basic constructions. For some people this is a refresher. Now we're going to make a one-point plane. You can decide how deep to make this plane. I'm going to make mine about this deep. Now to do this, I'm not just simply getting my straight edge and just bringing this up. I need to make sure that my straight edge is nice and straight. I need to make sure the T-square is nice and tight along the edge of my board to make sure that these become parallel. These two lines have to be parallel to each other. You cannot just get your straight edge and just make a line here and then bring this up here and make another line and say, okay, well, there it is. It doesn't work like that. In perspective, when we're in this class, anytime we're making a horizontal line, we have to use our T-square, not just the edge, but we need to make sure this line that we make is parallel with the horizon line. And the only way that works is if the T-square itself is lined up with the edge of your board. Okay, so let's make another one. We can actually make another one the same width, or the same depth. And we can use this height here. Just bring these lines across here and here. And I'm just going to make a mark here and here. Let me get my mechanical pencil to work. Doesn't like me. There it goes. So I'm going to make a point here and here. It's not going to be exactly the same width, but it is going to be at least the same depth. And I'm going to draw a line to the actual vanishing point. So when it comes to doing drawings like this, it is very helpful to be accurate with drawing to the vanishing point. You don't want to make the vanishing point too big. You don't want to make a big dot for it. You just want to make it a simple point. And when I think the shape is good enough, when I want to finalize it, I will line up to the vanishing point and I'll draw a harder line. I think most of you are using your mechanical pencil, and so I'm just making the line a little bit darker when I know it's accurate. Or let's say when you want to finalize it, or when I think it should be final, I will make a darker line. I'll make sure the tip is nice and sharp. Now, if you're using graphite, should you be going black with it? No, you shouldn't be going black with it and press hard, press really hard on your pencil. You just want to make it a little bit darker so it looks different than these lines. These lines are what we call construction lines. These lines are called object lines. Object lines define the actual shape. Construction lines are exactly what it sounds like. They just help you construct the drawing. Okay, so I'm going to do another one up here. This one's going to be a little bit bigger. And I'll make this one a little bit deeper. So when you guys are following along, do you have to draw exactly what I draw up here? No. Should you be approaching the same concepts? Yes. So you don't have to draw this exactly. Like, I will never go through your portfolio going, oh, this drawing is not exactly like mine. You get an F. It doesn't work like that. But do your concepts have to be the same? Yes, absolutely. All right, so I have a big one here. I'm going to do another one behind it. Now, it's not going to look like it's behind it. but I will show you what overlapping looks like in perspective, in a perspective drawing at least. This one is going to be a little bit longer, not longer, but it's going to be a little bit deeper into space. So when you see things like this, you can't tell which drawing is in front of the other. You can't tell what plane is in front of the other. What can I do to identify that this larger plane is overlapping this one? What do you think I can do? Now, you don't have to know anything about perspective to know this, but you guys have taken a drawing class before. You guys have taken drawing fundamentals and beginning drawing. What do? I could erase the line, but I want to see all of my construction lines. Because we already know that if I make this light enough, if it overlaps, I might be able, I'll still be able to see it, but you still see that it overlaps. What did you guys do in your beginning drawing class, or your drawing fundamentals class, when you had to make sure that you drew through? You guys know the term drawing through, I'm sure. What do you guys do?
Darken the front lines.
Darken the front lines, exactly. It's the same thing like what I did here. So if I darken my object line, it's going to look like it's overlapping this one. So that's exactly what I'm going to do. So this is the whole reason why we reiterate a line, or we make our object lines darker. It's so we can actually show overlapping. And overlapping, or showing an overlapping line, is what we call a depth cue. It cues us lets us know that an object is overlapped. But Toria, you are right. You could erase it, but a lot of this stuff I want to be able to see. I want to be able to see how you guys think. I want to be able to see a lot of this information. What would be important is to erase any lines that I shouldn't see. Anything that I overdrawn, like I could erase these if I wanted to. But these here, convergent lines, I never want, or hidden lines, I don't want to erase. Okay, so we have construction lines. Oh, allow me to make this a little bit bigger so you guys can see. Those are construction lines. These are object lines. These are also construction lines. But because it's hidden, we call them ghost lines as well. Ghost lines because these are ones that remain hidden or not easily seen. They are lighter. Construction lines are also pretty light. Ghost lines are very light. It seemed like the color change. It's kind of odd. Oh, sometimes I will let you know, sometimes this projector acts kind of funny. So you see, I mean, before you saw that a lot of the lines, you could actually see the red lines here, and you can see the blue lines clearly. Sometimes this projector goes off, or not goes off, but it goes kind of wonky. But on the video, all of these construction lines and ghost lines will remain red, and you will actually see these as blue. So just keep that in mind. So ghost lines, object lines, construction lines. Okay, so with the next 5 minutes, I want you to draw as many planes as possible. Okay? If you could get 5 planes down, that'll be great. But I also want you guys to draw vertical planes. So how do you draw a vertical plane? Use a 90-degree vertical line. The same way as you drew these. So I took my straight edge and I put my T-square on it to get a perfect vertical line that is perpendicular to it. And again, the only way to do that is you have to use a perfect 180-degree line that is parallel with the horizon line and also parallel with every other horizontal line. Draw a 90-degree line or vertical line. Draw a line to the vanishing point. I know you're going to go through some of your notes here or some of your abbreviations. It's not a big deal. And decide how deep to make it. And I want you to overlap some of these too. You could decide what's overlapping what. Even within these drawings, you can even do some cool stuff like this. Or you can take a plane and cut a window on one of the planes to expose something that's overlapping underneath it. Now, do you have to do stuff like this? You have to try. You may not be perfect at it, but you should at least try. Have some fun with it. And don't worry, after break we'll do some more. So all together, for this drawing, you should have about 15 planes, both vertical and horizontal. Okay. Now, do you have to have all this done before break? No, because we're going to be working on this after break too. Okay, does anybody have any questions? Okay. So again, we have 15 planes. At least 5 of the planes you're going to deconstruct. You can put some windows in here. You can take parts of them out. That way you can see some overlapping and practice good line weights. With this, you can see how large my paper is, and I still have a lot of room around here, and even in here and up here that I can actually draw some planes in. Your vertical planes don't just have to straddle this horizon line. I just initially put those here. You can certainly put some in here. I guess a rule of thumb is don't draw to infinity. Even though your lines do converge all the way to the vanishing point, don't keep your planes traveling all the way to infinity and just leave it there. You're going to need to show some restraint and some, I guess, sophistication with your drawing. So with this one, I'm going to keep this one slightly unfinished. Just so I can do some interesting things with this, with the bottom part. Well, that didn't work out. So you can even do stuff like this where you have a horizontal plane that's actually passing through a window. Sometimes it can be a little bit difficult to see things like that. So you can also do things like this too. You know, I have this top plane overlapping this one, and this one is literally passing through this. So you will see me do this from time to time, where I will tone something that is being overlapped. So you can actually see the overlap a little bit clearer. It's not required, but I know some of you will want to do that just to show some degree of clarity. It's like even in areas in here. Let me erase this. There. So sometimes with things like that, it can look a little bit more, a little bit clearer. So I just found out that this overhead projector, sometimes the color changes on the projector. Sometimes it goes cool, sometimes it goes warmer. So like right now, it's kind of like in between, so you can actually see the blue and the red, while other times you'll see it go very cool where you'll only see blue. So keep that in mind. It's going to happen with this specific projector, or these projectors. It happens in, I was just talking to one of my colleagues about it, and he's running into the same problem on his camera. So. You can also begin to do stuff like this, and it would probably be a good idea that you do that too. Connect some of them. You don't have to connect all of them, but you can certainly create a vertical plane connecting to a horizontal plane. And it adds an additional element to your drawing. And it kind of illustrates where we're going to be going with this stuff. You can even practice doing some repetition, similar to what we did on the first drawing that we did today. Even though these aren't squares, they're certainly rectangles, and you can show a degree of repetition. So the cool thing about repetition is you can, let's say I wasn't trying to draw 3 of them, but I was only trying to draw 2 that had the same distance apart in perspective. So I can do that. Actually, I found out that I actually did this wrong. So let me fix this. Sometimes when you see a mistake that you make, it's really good to fix it right away if you can, before it ruins your drawing. So what happened is I made an X from corner to corner, but I must have moved my straight edge, bless you. I must have moved my straight edge when I was doubling. Because it should have been here. And I actually didn't do it correctly. So So if you see a mistake, it's a really, really good habit to get into, is to fix it right away. That way it doesn't hinder any more of your drawing. There we go, that works better. So to reiterate, connect at least a few of these horizontal planes and vertical planes together. So if I have something like this and I want to connect one up here, I can certainly do that. I don't have to use exactly the same dimensions. I can even put a, okay. Take a look at what happens here. So I have 1, 2, 3, 4, 5. I have 5 that are repeated. But look what happens that they share in common. I know we haven't done any repetition in one-point perspective yet, but I showed you a little bit here, even though it wasn't done in a formal way. But I'm sure you can recognize this as being the first drawing that we worked on. I don't know why I didn't. Oh, here it is. The first drawing that we finished up today. You know, the repetition that we did here is actually illustrated here. Even though these aren't squares, you can see how I made an X from corner to corner, drew a line to the vanishing point, and then took this line from here to the bottom to the baseline to create the width of the next square. And I repeated this over and over again. But look what happens if you do it right. Something special happens because they all meet in a very specific place. They meet at a point. This is basically what we call an auxiliary vanishing point. We'll touch on this a little bit later. Auxiliary VP. All this is, it's like auxiliary vanishing point or a special vanishing point. What this allows me to do is take a look at everywhere that these cross, and I can actually line it up with this point. Now, where it falls is very specific. This is not just a random point. This point is actually below the vanishing point. Now, the distance is not as inconsequential, but where it is here, that is very specific. This line has a very specific term. It's called a central line of vision. Now, all a central line of vision is just a line that drops below the center of vision. That's all it is. Or below, in this case, below the vanishing point. But this is not happenstance. This is not a coincidence that these lines actually converge to a single vanishing point below the main vanishing point. It's not a coincidence. This is just something that happens specifically because this is in one-point perspective. This is my vanishing point. I'm trying to duplicate this rectangle into space to this vanishing point. So where these cross will always happen at an auxiliary vanishing point. Now, will this happen on something that is horizontal, on horizontal planes? Yes, it will. But it will not hit this. It will actually hit an auxiliary vanishing point on the horizon line itself. Okay, so I'll do one up here or a little bit higher since we're kind of talking about. No, we started talking about repetition, so I'll do one up here and I'll zoom in a little bit so you guys can see. Now, is this something that is necessary for you to do when you're drawing right now? No. This is just something a little bit extra. And it's something that we will touch on a little bit later too, on a later drawing. Well, theoretically, it should hit the same place. So we'll try to make it work. Okay, so I'm just going to draw a main one here, and I'll repeat it a few times. We'll see where they line up. So when I show you guys stuff like this, like little tangents of information, it's not something that you need to do in your drawing, your current drawing. This is just something to reflect on. Maybe it's something that you can retain later on for, so when we actually work on it, you'll be able to recall it a little bit easier. All right, so I made an X from corner to corner. Now I'm going to take this corner. Actually, I'm going to do it here from the bottom. I can do it here. Oh, actually, no. I think I have to do it here. I'm going to draw a line from here to here, all the way down here. I'm going to extend my line, though. Okay, so it hits here. So there's my repeated rectangle. Okay. So I'm going to make an X again. But technically I don't have to, because I already know where my midpoint is. My midpoint is here. So technically I don't have to do that. But I'm going to extend this so you can actually see how it converges. I may not be able to show exactly where it converges to on the horizon line, but you will certainly see these lines converge, meaning they will appear to come together. See how they're converging? Okay, so it hits here. I'll do another one. Okay, 1, 2, 3, 4. You can see these three lines do begin to converge. They're actually going to, they will actually converge off my paper. So somewhere over here. Now they will actually converge to the same spot along this horizon line. So let's see exactly. Let's see how close. I can probably show you on the camera. I can draw on the table because it's mine. Let's see where it will connect to. So it should connect right here. Let's see if the other ones will connect. This is my little auxiliary vanishing point. I don't know if you guys can see it. Yeah, there you go. Look, they all connect to it. 1, 2, and 3. Okay. And it is on the horizon line. Is it outside the cone of vision? Yes, it is. It doesn't matter. The object itself is not outside of the cone of vision. Well, this one is, but these aren't. Okay. So how many planes? 15. Okay, make sure you write it down. 15 planes. You can give yourself a little note at the bottom by your title. That's fine. 15. Okay, so some of you are noticing Kind of like this optical illusion that happens with, let me turn this down. Some of you guys are seeing this optical illusion that happens when you have verticals that are really close to the center of vision, or horizontals that are really close to the horizon line. Okay, you have this, like I said, you have this optical illusion. So let me draw a vertical plane here. Yeah, I'll put one here. I'll put one off to the far right. So some of you are noticing that the lowest line converging to the vanishing point, it looks kind of strange here because it looks really thin. Not thin, but it looks a little bit odd because it's not as dramatic as this one up here. Okay, can anyone tell me why? Can anyone tell me why this is happening? Why it looks the way it does? It's closest to the horizon line, yes, of course, absolutely. So the reason why it looks like this, any horizontal line that is closest to the horizon line is going to look flatter and flatter and flatter. Okay, so, I mean, I think all of us can understand that. But let's look at a horizontal plane. I'm going to, let me see, where can I place one? I'm running out of room. Okay. So I'll place a horizontal plane here, off to the side. I think you guys can see it here. Here and here. Okay, so look how razor thin this is. I mean, these angles are very acute. They're tiny. Almost too challenging to figure out where they start and where they end. And it's because it's closer to the horizon line. Let's look at a plane that is exactly roughly the same width or dimensions and further away from the horizon line. Let's place it down here. It's going to be hidden a little bit, but we'll place it, actually we'll place it way up here. That'll be easier. You can see it a little bit closer, or a little bit easier. So I'm going to take these corners, raise them up here. Okay, I'm going to have these converge to the vanishing point. So all I did is I took the dimensions, or the width of this first line here, brought it up here. And let's see where it ends. It ends about right here, so we can probably use that. And we'll talk about a real-world example. Let's see if that's accurate. Yeah, that's pretty accurate. It's about right there. Okay. Okay, so let's talk about why this looks the way it does. So this plane up here is visually about 4 inches above the horizon line, versus this one here that's less than an inch above the horizon line. because it is so far above the horizon line, or let's say the eye level, you can see more of the actual plane. The closer you get to the horizon line, it's similar to something like this. Now if you place this triangle above your head, you can actually see that it's a 45-90 triangle. The closer it gets to your actual eye level, the less you see of it. Okay. Same thing with this. The further away this vertical plane is from your center of vision, the more you see it. The further away you can actually see it, but the closer it gets to your center of vision, it becomes razor thin. So, with that said, when you guys are drawing, you have to you're going to also have to think about the aesthetic quality of your drawing. So, is this correct? Yes. Is it a horizontal plane? Yes, it is a horizontal plane. Can I run into problems later on if I continue to do a lot of planes like this that are closer to the horizon line? Yeah, I probably can. Okay. Same thing goes with the center of vision. The closer I get a vertical plane to the center of vision, I can actually run into some optical illusions that could ruin a drawing. So it is a good rule of thumb to try to be careful with placing full planes, horizontal planes too close to the horizon line, or horizontal planes too close to the central line of vision or the center of vision, because you get this weird illusion. Okay. Now, is it still in perspective? Yes, but the problem solving, like trying to figure out where these corners are, it can be very, very challenging. So it's something to keep in mind. Okay, any questions? We went through a lot of information today. A lot of information on the same drawing, but nevertheless, we still went through a lot of information. Yes? That's a great question. We're going to actually, I will show you guys right now, and I'll show you guys why it looks the way it does on Thursday, because that's exactly what we're going to be working on. Now, first and foremost, can I draw a square plane on this? Yes, I can. All right, so let me draw one. I'll draw one here that you guys are used to seeing. Now, is this in perspective? No, it's not. This is a 90-degree square, one similar to like if you're in a bathroom, in a steamy bathroom, and you draw a square on the mirror, it's kind of the same thing. But in perspective, how would I draw a square? Well, I still have to use a 45-degree angle. I'm going to get rid of this. You guys already know it's there. You guys already know that's actually a square. Oh, in order for me to draw, I'm going to draw a square plane in here. In order for me to draw a square plane that's converging to the vanishing point, that's in perspective, I still need a 45-degree line. I can't use this here. I can't use a visually 45-degree line. I have to use one that's in perspective. I have to use one that's in one-point perspective. And this is what we're going to do on Thursday. Okay, so let's back it up a little bit. I'm going to drop my vertical down. This is my central line of vision. I need a 45-degree angle. That's in perspective. Now, is this in perspective? No, it's not in perspective. Oh, actually, let me show you a little bit lower. There we go. Okay. So is this in perspective? No, but this is part of what we call the structural approach. The structural approach or structured approach is something very standard that we do in 1-point, 2-point, and 3-point perspective, which means we always have a horizon line, we have a vanishing point, we have a station point. I'm going to put it down right here because we'll talk about this on Thursday. And we also have this. This is a diagonal vanishing point. I know I'm piling on the terms. I'm just going to put diagonal VP for now. I know it's really light, but we're going to talk about this really very heavy on Thursday. Let me make this a little bit darker. Okay, so like I said, in order to draw a square in perspective, we have to have a 45-degree angle. Well, we have to have it in perspective. Now, this is, you can see the 45-degree angle here. Is it in perspective? No. Is it on part of the structured approach? Yes, absolutely. So if I were to draw two lines converging to the vanishing point, and I want to make this side a square, a vertical. Oh, actually, no, let's do this top part. This one here. If I wanted to make this upper plane here a square, and you can see where we're going with this, it's going to look like a cube. In order to make this a square, I need a 45-degree angle. Now, I can't use this specific angle because it needs to be in perspective. But can I use this? Diagonal vanishing point. Can I use your big straight edge? Okay, so watch. I'm going to take my diagonal vanishing point. I'm going to draw a line to the furthest corner. Draw a line to it, if I can do that. Here we go. Now, wherever this line crosses here, gives me the depth of my square. And there's my square. Now, diagonal vanishing point, because it's on the horizon line, works for every horizontal plane. Okay? But we can't use it for vertical planes. Okay? The reason why is this. I can't draw a line to any of these corners to give me a proper depth. So, thank you. But I have this. I have my diagonal vanishing point. I have my station point. It's on this vertical central line of vision. I can draw a line to the furthest corner, which is here. And like magic, oh, it doesn't line up. It comes close to lining up. Oh, let me check my lines really quick. This is the way you double check everything. Oh, it's close enough. Okay, I fudged it a little bit. Okay, can you guys see it? Okay, so we're going to talk about this very, very heavily on Thursday, so I'm glad you brought it up. Station point is used for any vertical square plane, and diagonal vanishing point is used for every horizontal plane that's parallel with the horizon line. Any square. Yes?